In Part 7 of the Unit 9 notes, we are going to be covering percent composition calculations. Percent composition, the percentage by mass of each element within a compound. This can be calculated using masses provided within a problem or the molar mass based on the chemical formula. So if you were given the masses of each component within the problem, you would simply take the mass of the element and then divide by the total mass of the sample. If you were only given a chemical formula, instead you would use the molar masses on the periodic table. So you'd use the molar mass of the element, and then you would divide by the molar mass of the total compound. And you would simply do this for each of the elements that are listed. In our first checkpoint question, we are told that we have a 13.60 gram sample. It contains only magnesium and oxygen. 5.40 grams of oxygen is obtained. And we want to know the percent composition. We're not actually given the formula here, so we're going to be using the masses in order to calculate this out. The first thing that we should do is determine the mass of magnesium. We know that the total mass is 13.60. We know there are only two things, and we know that the oxygen is 5.40 grams. So if we just do some subtraction here, we can see that the magnesium is going to be 8.20 grams. Now our percentage is going to be the mass of the individual element divided by the total mass of the sample, which in this case is 13.60 grams. And then we're going to multiply by 100. The mass of the sample is the same for both of these elements. So we have 13.60 in the denominator for both. We multiply by 100. We end up with 60.3% for the magnesium. And for the oxygen, we have 39.7%. For both of these, I rounded my final answer to 3 significant figures, since both of these numbers had 3 sig figs. In our next example, it's very similar. We are given the mass for the entire sample. So it's our mercury 2 oxide. And then we have a mass of mercury. Again, they don't give us the mass of one of the two elements. So anytime they give you a situation like that, you can simply subtract to find the missing piece. We have two elements in this compound. We have mercury and we have oxygen. We know that the mercury is 13.2 grams. We don't know how much oxygen there is, so we can just subtract these two and find that we have 1.0 grams of oxygen. We're going to divide both of these by the 14.2 grams since that's the total amount. Then we're going to multiply by 100 to make it a percentage. For the mercury, that is going to come out to 93.0%. And for the oxygen, that is going to come out to 7.0%. The significant figures are different for these two values because in this problem we had 3 versus 3, and this one we had 2 versus 3. So the 7.0, I had to keep that at 2 significant figures. In this percent composition problem, we are given a formula instead of the masses of each individual element. So in order to solve this, we're going to break it down into carbon and hydrogen. And what we want to do is take into account the fact that we have 3 carbons here. So each one of those carbons has a mass of 12.01 grams. I'm going to multiply that by 3. So that's a total of 36.03 grams. For the hydrogens, I have 8, and each one is 1.01. So that's a total mass of 8.08 grams. Now the denominator is always the mass of the entire formula. So in this case, I'm just going to be adding these two together because I have 3 carbons and then I have the 8 hydrogens. So this has a total molar mass of 44.11 grams. So I'm going to use that as the denominator in both of these. And I end up with 81.68% for my carbon and 18.3% for my hydrogen. All right, we have one more checkpoint question here. This one is a little different just because there are more elements present. Otherwise, it's the same general process. We're going to be breaking this down into a sodium, a hydrogen, a carbon, and an oxygen. The mass of a single sodium is going to be 22.99 grams. A single hydrogen is 1.01. A single carbon is 12.01. And for the oxygen, there's actually 3 of them here. So if I add all of that up, it's going to be 48.00 grams. If I were to add this all together, that gives me a total molar mass of 84.01 grams for this sodium hydrogen carbonate. So this is going to be the denominator for all 4 of my calculations. So I'm going to divide each of these by 84.01. We're going to multiply all of them by 100. All right, for our sodium, that's going to come out to 27.37%. Our hydrogen is wrong line. Our hydrogen is 1.20%. Our carbon is 14.30%. And our oxygen is 57.14%. That concludes part 7 of the Unit 9 notes. When we come back in part 8, we are going to be looking at empirical formulas.